Section 4.2 Applications of Linear Equations. So as we began talking in section 4.1 about solving systems of linear equations, now we're going to look at how we can apply those systems to solving word problems. And a lot of these, especially the initial types of word problems, will look kind of familiar. You've probably solved problems like this before, but you might not have used matrix methods. But we're going to be using matrix methods for these. Okay, so here's an example. Suppose you have a bag of 706 nickels and dimes worth $48.60 altogether. How many coins of each type do you have? So as I solve this, I'm also going to talk about methods of solution for word problems. And for me, I guess the number one thing that you need to do, and it always sounds kind of silly when you say this, but it's so true. You need to read the problem closely. That's the most important thing. And what do we mean by that? Well, when I say read the problem closely, I mean, and I guess maybe these are other instructions, but they're part of reading the problem closely, is identify the question. What is the question? That's kind of the most important thing, because if you identify the question, then you can name the unknowns. You can give them variable names. And which is sort of the same thing, but I'm going to write it down anyway. You can make it clear what you are trying to find. And a lot of times what people mess up on is they don't take this seriously. They think, oh, well, I'm just trying to find some coins or something. But you've got to be very explicit. What are you trying to find? Is it the number of coins? Is it the value? Etc., etc. And you need to write that down, because if you don't write it down, you will forget and you will make a mistake. Okay? So we read the problem somewhat closely. What's the question? Well, it's the thing that has how many in front of it, right? So how many coins of each type do you have? That's the question. So the unknowns and the thing that we are trying to find is the number of coins of each type. So the number of nickels, that's one thing that we're trying to find. And we're also trying to find the number of dimes. So I'm going to choose variables that are kind of expressive of this. So I'm going to let n be the number of nickels and d be the number of dimes. Okay. Now, at some point you have to start writing down equations. So I guess now is that point. So I always try to find the easiest equation to write first. And in this case, the easiest equation, in my opinion, is a total amount equation. Now, you can't always write a total amount equation, but very often you can. Let me erase that. So my total amount equation now this is not value, this is number of stuff. So the total amount equation is the number of nickels plus the number of dimes is equal to 706. And that's just taken directly from this right here. We have a bag of 706 nickels and dimes. So in math form, that's n plus d equals 706. Okay? Now the next thing is we have a value. I mean, we kind of have to look through and find all the numbers and think about what those numbers relate to. So this number relates to value. So we can also write a total value equation. So the total value that I have is $48.60. And if I write this in words, let's do this. It's the nickel value plus the dime value. And now let's think about what is the nickel value. So the nickel value is the number of nickels times the value per nickel, right? So if I have 5 nickels and they're worth, 5 cents each, right? That's 25 cents. So number of nickels times the value. All right, and so to that nickel value, we are going to add the dime value, which is pretty much the exact same setup. It's the number of dimes times the value per dime. And altogether, this has got to add up to be $48.60. So we're well on our way to actually having the full system here. This is our first part of the system. Now we just need to put symbols in for the second equation. Let me make this a bit larger, the window a bit larger. There we go. Okay, so the number of nickels we don't know. That's n. The value per nickel, now you do know this, although a lot of times people mess this up. What is the value of a nickel? It's 5 cents, right? So this is going to be 0.05. If you put 0.5, that would be 50 cents. So just be careful that you don't make a little mistake like that and throw everything off. Now the number of dimes, that's D. And the value of a dime is 0.1. I'll put that 0 there just to remind you, I think sometimes people feel more comfortable with that, but we know this is a hundredth, right? I'm sorry, a tenth, what am I saying? That's a tenth and that's a hundredth. So this is a dime. Okay. Now that's it. This is our second equation, and that is our first equation. So now we are really ready to solve this. And this is my system of two linear equations. And really, you're free to use whatever method you want to solve this. I'm going to use matrices because that's kind of the subject of this. We spent a lot of time developing our matrix methods. So I'll show you actually, well, let me write it off to the side here. So our matrix system, what's it going to look like? Is going to be, first we have our coefficient matrix, and each of these, the coefficient is 1 and 1, and this one's 0.05, and this one is 0.1. So that's my coefficient matrix, and then I'd have the variable matrix n over d. Sorry, I'm getting this kind of squeezed up in the corner here, but and then that's equal to the this constant matrix, which the first entry is 706 and the second entry is $48.60. Okay, and then what we're going to do is take the inverse of this matrix and multiply it by this matrix. So that would ultimately, that'll be 1.05.1 inverse times 706, $48.60. Then it's just a matter of, that's pretty illegible, isn't it? $48.60, a little slightly better. And then we want to put all that in the calculator. So this is a 2x2 matrix. Okay, so let's quickly do that. I'm having trouble with my calculator. There it is. Okay. I'm going to clear everything here. Go to second matrix. Oops, where did I go? Second matrix, edit, A, 2x2, 1.05. And as always, when you're working with matrices, you have to be very careful about keeping things in order. Now let's exit this and go back to the matrix screen and edit matrix B. This is a 2x1. $706 and $48.60. And let me just double check that I didn't forget my numbers. Yeah, 706. I was thinking it was something else. Okay, all right, good. So now we just need to go call up our matrices and not edit, just names, and call up matrix A, hit that inverse button, very important, multiplication button, and now I call it matrix B. And there we go. So the first entry, because n was the first variable that appeared in our equation, n is the first entry, so that's 440 and 266. All right, so here's our written out solution. Okay, as you can see, there's our conclusion. And that's a simple example of using a matrix method to solve a 2x2 system. All right, let's ramp it up a bit, look at something slightly harder. Mixture problems are something that have bedeviled students for many years, and so they're still here, but we're going to use a matrix method to solve this mixture problem. So suppose large quantities of both a 4% methanol solution and a 14% methanol solution are available in a stockroom. How many gallons of each, remember looking for the question, how many gallons of each must be mixed in order to get 50 gallons of a 7% methanol solution? So here's my question. And when it says how many gallons of each, that's telling me what my variables are. So I'm going to need a variable for gallons of 4% methanol, and I need a variable for gallons of 14 excuse me, 14% methanol. So I'm just going to call this one X, and I'm going to call this one Y. So we just have to remember that X is the 4%, Y is the 14%. Now, with a mixture problem, I think sometimes people have a hard time kind of conceptualizing this a bit more, but we still have a total amount equation, because the total amount that we want to get is 50 gallons. And this is just the number of gallons of each of them. So I can still write down that x plus y equals 50%. And that's still a valid equation. Now, what other information do I have that I haven't used? And that's also always a good thing to ask when you're solving word problems. So the other information that I haven't used is my percent information, that I want to get 50 gallons of a 7%. So the way I like to think about this is the other type of equation that I can write is an equation that's relating the amounts of pure methanol contributed by each solution. So let me go to my whiteboard, and I want to make a new one here. So a pure methanol equation. I think I'm probably going to run out of time in this video, so we'll probably have to finish this in the next lecture. But I'll go ahead for a moment here. So my pure methanol equation is methanol contributed by the 4% plus the methanol contributed by the 14% has got to be equal to the methanol, the total pure methanol in the final solution. Sorry, I'm having trouble writing here. Okay, so I'm out of time on this video, so we will pick this up in the next one.